Hi, welcome to another PlayBASIC tutorial. Today we're going to look at something called functions. I'm going to assume straight off the bat that you are familiar with variables and you're familiar with things like control statements like goTo and Gosub. Primarily Gosub. If you're not, I guess we'll just brush over it a little bit. With program flow, or control, we can have things like loops, and we can branch away from our current executing piece of code, do something else, and come back. That's what a Gosub control structure is all about. To do that, we need to have a label of our subroutine. We'll call it print lines. That can be our little bit of subroutine code there. And we'll have a for next here that does something, 10 times. Sync, wait key, end. Right, now, let's say we wanted to print a row of lines here. Could do other things there as well, but for now we'll just have a little return statement. And I'll place an end there at the end there, just to make sure we don't get any faults. So where we want to call this particular piece of useless kind of code, this print lines subroutine, we would go sub print lines. Don't need the colon, because the colon's just for declaring the label, which has to be hard up against the left-hand margin, by the way. Let's run it and see what we get. We get a bunch of lines all in a row. What's happening is the code PB is running down, starting a loop structure, looping through the code in between those two statements from 0 to 10. So loop, the first time through, loop is 0, get down to, does whatever the code tells it to do in here, hits the next statement, returns up here, loops 1, and so forth. When it sees a Gosub, it drops a breadcrumb onto the stack and then changes control or execution changes to wherever this label is in the code, which is worked out for us by the compiler, thankfully. So we don't need line numbers anymore. Okay, so our routine here, when we call Gosub and our control changes, we end up down here. This actual label doesn't do anything, so it runs this piece of code here, which does a print statement and so forth. We have more print statements there if you wanted to. I don't know, you could do something like line number. Print the line number, or it should be loop number at least, shouldn't it? Because the LP variable is used in this loop counter up here, so it should print the loop counter in this piece of code. So we'll print one row of characters, our loop counter stuff here, put another row of characters. Well, we don't really need that row there. Put this at the end. So this will put an end marker on it. We print this row in the subroutine, do this, and then we return. So this subroutine here jumps out of our loop. So it simplifies the code here. We're jumping to some piece of code that's either long and messy that won't fit nicely inside our loop to do something else, and then we're returning back to that point of call to continue this loop going until we reach the end of the loop. So we'll run it. Bit of a crash course there, I know. There are some stuff on loops already done. Please go check those out up front. And there's some things on Gosub and GoTo already as well. They're very old school in terms of BASIC. These are kind of old mechanisms that we've kept. Some people like it, some people don't. They do have benefits, but I guess I'll get to that some other later point. But there's detriments as well, So don't be fooled to think this is the best way of doing something. There's no best way. To determine any kind of best, you've got to work out what's my objective. Am I trying to make the code small? Am I trying to make the code fast? Or am I trying to make it, somewhere in the middle, medium sized and small and reasonably fast? Okay, now today we want to get to functions. What we could do is make a function out of print lines. Now, one of the problems with subroutines is that we have to have an exit mechanism here that returns us back to wherever the call came in for this label. So if we hit this piece of code here, places the current location on the stack, then it branches to wherever this label is, jumps to this location, does this stuff here. The return pops the last value on the stack, and that should be the return value to go back to. In terms of BASIC, it's probably easiest to think about line numbers. If I miss this return statement out, this program will behave different altogether. What's happening is that it's never, we're making the call, but we're never actually coming back from this subroutine here. There's no indication at all as to what's happening. So in bigger programs, what tends to happen is it's quite common for people to miss a return statement, or what can happen is when you have lots of subroutines is that if you're cutting and pasting code around a little bit, you might miss a return statement, or you might move one, and all of a sudden the behaviour of your program changes in some weird way, and you've got to go find what the problem is. What we could do is we could make a thing called a function. Actually, I'll leave that there. And a function is kind of a compartmentalized piece of code. It has a name. We pass it some parameters if you want to pass it parameters, and it can return data back from it if you want it to. To make a similar function as the print lines, we would type the word function. Oh, if I can spell it. We'll call this one print lines function, something quite dorky. At the end of the function name, this is the function name, it's quite long in this case, we need a bracket and another bracket. For inside these brackets here would be a list of what parameters, or generally variable names or array names, that are being passed into the function when it's called. In this case, we won't put any. Now, to close the function, we'll put if we try and compile that the way it is, let's do a test. We get an error saying that this function here, the one that's highlighted, is missing its closing end statement. So that's our first benefit from using a function. The compiler can detect those stuff ups that we make when we move code around, or perhaps you've deleted something, not noticed you've removed an end statement, which does happen. So all we need is the end function there at the end, and now it should be happy. If we compile and run it, it is happy. We're not calling our function yet, it's not doing anything. Let's just place this code from the subroutine inside the function. And it's time to get rid of this piece of code, this subroutine, and convert our code to using our function. Now, to call the function, we just call its name. So one way of thinking about this is when we create functions, or we make our own functions, it's like making your own commands. So the command names up here, sync, print, or create sprite or something like that. We just call their name and give them some parameters. Well, same for our function. We just type its name and give it its parameters. In this case, it doesn't have any parameters. Let's run it and see what we get. We get something we may not be expecting. If you look closely on the screen, you'll notice that loop counter is always 0. This is introducing a new concept, and one that's hard to wrap your head around initially, and it's referred to as scope. If I run this program and debug, hit F7, hopefully you can see this stuff on screen, go to variables, we'll see under this label called main, we've got a variable called loop. If I click it, it shows me the value in decimal, hex, and binary. But I've also got another label here called print lines function. If I go to that, I've also got a variable in there called loop, and it equals 0. Now, what's actually occurring here is we have two different scopes, main and the function scope, or container is another way of thinking about it. Inside the function, or inside that little self-contained container, I did say container. Inside that, all the variables in there are only ever exist inside the function, and they are not visible externally, which is actually a handy thing, but initially it feels quite limiting. Now what we need to do to make this program work, there's a few different ways we can do it. We could do this. We could declare loop as global. Now how this works is that we're declaring loop variable as global, which means that it's visible within the main scope, which is all the scope that's not inside a function. And then when the compiler sees a function, it goes, okay, cool, I'm in a function here, and it sees a variable name like loop. It goes, hang on, does that variable, has it been declared global elsewhere? If it has been, it will use that same version of the variable, and this should make it work. It's not how we should do it though. Okay, so we've got it to work, but it's not really a great solution. What we probably should be doing is defining a parameter in our function and passing it through. Now, these are just a list of variables, basically, or array handles. Here we're going to use an integer variable, so we just have to give it a name. And you can put as integer if you like, but you don't really need to. We'll call this one here loop counter. Now what we have to do is, since the person calling the function, calling our print lines function, is going to provide or pass this value into our function, this value here is going to be passed into by whoever's calling the function. Once it's inside there, that value is now known as loop counter. So in our print statement, we need to have that replicated there. It's no longer the same variable as loop, but they're different things. If I try and compile it, we'll get an error. It's telling us that parameter 1 is the incorrect type. So the compiler's expecting there to be a parameter within these brackets, and we'll use the loop variable for that parameter, and it needs to be integer. Now let's try and run it again, and we're back to working. Now, this might not seem very useful, but it's all about compartmentalizing your programs. Functions are really good for hiding away complexity in your program inside your own sort of personalized command. So, what's a good example of one? let's say you wanted to have you need to compute a math calculation. You need to find the distance between 2 points. Standard sort of distance function stuff. Now, PB has a function built in to do this, but we'll make our own function for the sake of argument. It's still down the bottom here. So we write function. We might call it custom distance, and in 2 dimensions we need to provide the x and y coordinate of the object 1 or point 1 or whatever you want to call it, the x and y coordinates of the second point. So there we've got 4 variables we're going to be passing into this function, and they'll be called, well, here we could call them coordinate x or something like that. I tend to always use x and y for those kind of variables because they're short and easy to remember, and some people don't do that, but that's the way I like to do it. I mean, these variables could be anything. You could call it supercalifragilisticexpialidocious for all I care. If you can type it all the time and get it right, fantastic. Okay, so to compute that, we get the distance between so we get the difference between these, x1 I'll say it's we'll call it dx for difference of x, absolute of, sorry, I'm sort of rambling on here a little bit. Y. So now we've localized, we've got the vector between the two. The distance is going to be the square root of x by x plus y by y. Now that should compute our distance, but since this is the kind of function that we're building to call elsewhere in our code, we need to return this variable that we've finally computed. In this case, it's distance here, this distance variable. And we do that the same way. We place the return value after the end statement. So these are, you can think of these as your inputs into the function, and this is your output from the function. So it's getting piped in here, doing whatever it needs to do here, in this case computing the distance, and then just returning that distance to the caller. Let's try that. So we'll go up the top here. I'll do it at the very top, we'll leave the other code there, because I want to cut and paste that to the board afterwards. If I just call this function here, we should work, but nothing should happen. Why is that? Well, we haven't done anything with the return value for starters. So I'll call out this variable. Oh, no. Call it just distance. Distance, sorry, dist, short for distance. We'll give it 2 values. Say the first coordinate would be at 100, 100. The next one is going to be at 700 and 300. When PB sees this expression, it will call this function and it will pass to this function these values in the appropriate order, and then change control to the function or jump to that function. Once it jumps to this function, it sets the values up, these variables here, as whatever the values that were passed in. So x1 will have the appropriate value, y1 will have the appropriate value that the user is passing in. Once we are there, the code just behaves as normal. We get to the end and it returns this value on the stack back to the caller. So once the function is completed wherever it's doing, we don't really know what the function is doing, but in this case we do. We're gonna, the result is then just assigned to this distance variable here. If I run this again, we won't see anything different. So we need to print this out. Print distance, put a sync and a wait key there to stop the rest of that code from running. Put end there as well. Okay, we've got a value there. I don't know if that's correct, but let's just say it is. All right, and this is our very quick startup to using functions. If you wanted these variables here to be floating point, you could tag them with the hash, which is standard in BASIC for float. Don't forget that you have to tag the rest of them there. Because the square root operation is actually a floating point operation. You should get about the same result anyway. But sometimes, you know, having integers can be, it's not what you want. You want to pass in floats. If you wanted to pass in a string, let's have a look at our, let's say you've got a bit of code that you want to do some operations to a string, or we might just pull this up the top here. No, yeah, sorry, we'll get to that first. We'll just jump into it. Let's have a, I don't know. Let's say it's a process string or something. We'll call the string being passed in as, you know, my string. Hit the end function. We need that to close the function out. Let's say our function here is doing, I don't know, a replacement or something like that, or maybe a trim, or maybe it's doing 3 or 4 different things at once. Who knows? We're kind of just coming up with this on the spot. So we might go trim, tell it to trim any leading slash characters, and replace, I don't know. Seriously, I can't even think of something. We want to replace any, let's say we replace all the spaces with the tilde character. Yeah, okay. Now, if we just ran this function here and use that in a, we call it in an expression, we wouldn't get our result back. So we need to actually have this my string returned at the end. Hopefully. Let's try this little example at the top here. We'll just print the result out from this. My string. We'll make a bit of a literal string up here. Our string's going to trim those off from here. PlayBASIC. Oh, I want to say hello world. Oops. Hello world. And we're expecting it to our function to remove the slashes from the start and finish and replace this space character with something else. I've forgotten what it was already. And there it is. Put the tilde character in the middle. So integers, floats, variables, they're all pretty much interchangeable. You just tag it appropriately, and that's what will get passed in and out. If something has a string parameter, then you can't pass an integer directly into it. So I couldn't call this function here, for example. Again, couldn't put the number 1, 2, 3, 4, 5, 6 in there. It's telling us here the process string parameter 1 is incorrect type, expecting string data type. So I provide it with an integer, and it wants me to give it a string. So I would just put it, in this case, make it a literal string. That should make it happy. Nothing's altered in that string because it didn't have any slashes in it or spaces. If I put some spaces at the start, we should get some tilde characters around it. So the beauty of having these, or setting things up in functions, is that the compiler's more aware it's more aware of how they work, so it knows that a function has an entry point and an exit point. You can have multiple exits, but we'll get to that some other point. The function's name, all functions need a name and a parameter list. The variables inside the function are local to the function. They only exist inside this function. So even though they might have the same name as something else used above it, or in a different function, for example, they are different versions of the variable. So don't expect those values to be the same or those strings to be the same. They're not. And the main one is that PB is actually quite strict about the layout of this code. If I indent that function, we're going to get a compile time error. It's going, I don't know what process string is because it's not defined. And it's true because all functions have to be hard up against the margin. And the reasoning for that is actually an old conversation about stacking expressions. Some people like that stuff, some people don't. And in BASIC it's a bit of a, it's not really a loved thing. What I mean is you have this code here, and you can stack all the code onto a line. You know, some languages allow that kind of stuff to happen, other languages don't, and in our case we just don't. It was actually kind of a unanimous thing. A lot of those choices were made by probably the initial beta testing group. I must actually publish those old conversations. They're probably worth while having a look at, and you might be surprised at what was going on. Anyway, so sorry about this really crude introduction to functions, but this is where we are initially. If you want to see some practical uses of functions, check out my tutorial series on writing an XML phraser. That's entirely function based. We're writing a little interface, our one little command set, which you would then include into other programs upon request. But for now, functions are just something that we can help to simplify our big mess of code into small modular parts. I mean, if you need this function here in another project, you just cut and paste it, plug it in, and it will work the same way as what it does here. Sometimes that's not the case. You have some dependencies on functions, like a function has a parameter that's requiring a type structure to be declared, or that kind of thing. But for the time being, this is where we are. Okay, thanks for watching. Hope we've got some sort of idea of what this function stuff is. Make sure you check out the help files. There is a few tutorials up in here. So head up to about, where are we? Down here and under Learn Programming, there's a section called Types, and go for your life. This one sort of follows one basic idea, and So you can sort of click and look at different parts of that as you go through. But, you know, worth a read. I'm sure with a bit of, if you're looking at that information, looking at examples on the forums of how other people have used functions, the mystery will disappear quickly. The scope issues will probably pop their heads up a few times where you're banging your head going, geez, why can't I see this variable? Well, and that happens. Actually, we'll just go over that again. So, if we just have a quick look in our little program here, where we've got this section of code here. This is the main scope section. So any variable used within in this section here, we get rid of that there. We just run the whole thing. So we're calling our process string function a few times. We're calling our calc distance function. I'll leave that distance there. I need that to show this behaviour. We're doing our print lines function, waiting and then ending. So we should be able to see, all this part here is this is within the main scope or global scope, whatever you want to call it. We refer to it generally as main. So all the variables here live, any variable declared in this main section, in other words, any code that's outside of a function, the variables will be in that main. This goes for arrays as well. So in this case here, we'll have two variables in main, distance and loop, as far as I can see. And within the functions, they've got their own variables. This one has loop counter. This one here has its own variables. It's got 4 of them, or 5 of them actually. Just to make that more obvious, we'll say this is the distance result, we'll call it. Better change that. So I can see that, just so I can see in a second, they're not the same variable. Here we're passing in something called myString, doing some operations on it, and then returning it out at the end. To run this in debug, the program does what it's meant to do. We click stop, go to variables. We can see in main we have 2 variables, distance and loop. Inside print lines we've got 1 variable. Inside custom distance we've got our, is it 6? No. And inside processing string we have 1. So those variables are, the variables inside the functions here are they are local, only visible inside the function. They can't be accessed outside of the function. You can, if you want to get something out of a function, you have to return it through the end function statement and then call it like a function call, like a math function you would normally call. Okay. I think we're probably going a bit overboard now. So I hope that's giving you some basis. Yeah, please check the documentation and go check out the XML series that is writing a phraser from scratch, all in functions. Thanks for watching, and I'll catch you next time. Bye.